The topic of this pencast is solving for a different variable in a formula. We also call that solving literal equations. My name is Darren Lacoste. A literal equation is a formula that establishes a relationship between two or more variables or quantities. Sometimes a formula is not solved for the variable we want. Solving for a different variable in a formula is a lot like solving an equation with just one variable. The goal is the same: isolate the desired variable using valid mathematical methods. These methods include, but are not limited to, the addition property of equality, the multiplication property of equality, and the distributive property. Let's apply these concepts to an example. Solve the literal equation, or the formula, d equals RT for t. You might recognize this formula. This is the distance equals rate times time formula. Now, if you weren't sure how to work with a literal equation, you might remind yourself that working with a literal equation is a lot like solving an equation with just one variable. For the moment, let's imagine that the d is a 10 and that the r is a 5. D and r are variables. They could be 10 and 5, so let's temporarily assume that they are. If you had 10 equals 5t, that is an equation with just one variable, and you can solve for the value of that variable by using the properties listed. In this case, the 5 and the t are being multiplied, and we want to undo multiplication with division. So to isolate the t, we divide both sides by 5. This gives us 10 divided by 5 and 5t divided by 5. Since we divided both sides by the same quantity, it remains equal, and we can put this equal sign there. Now we've got a 5 up top and a 5 down below. Since neither of them is being added or subtracted, those are canceled. On the right side, we just have t. On the left side, we have 10 over 5, which is 2. So we have our solution, t equals 2. Now, of course, this wasn't the problem we were asked to solve. The problem we were asked to solve was rearrange d equals RT to have it in terms of t. We want t equals something. So let's go ahead and now attempt that using the same methodology. We'll start once again by writing the equation, d equals RT. Well, now instead of saying that 5 and t are being multiplied, we say that r and t are being multiplied. And we use the same methodology. We want to get t by itself. So we divide both sides by r. So we have d over r, and we have rt over r. Since we divided both sides by the same quantity, they are equal, and we can write this equal sign. Once again, the r's cancel. Note that neither r is being added or subtracted, therefore we can cancel it. And that leaves us with d over r equals t. We have solved this literal equation, the formula d equals rt, for the variable t, and we have that t equals d over r. Let's try another example. In the United States, temperature is measured with either the Fahrenheit or the Celsius temperature scales. To convert Fahrenheit degrees, F, to Celsius degrees, C, the formula, C equals 5/9 of the quantity F minus 32, can be used. This problem has two parts. Part A, solve the formula for F to find a formula that converts Celsius degrees to Fahrenheit degrees. Part B, if the outside temperature is 20 degrees Celsius, find the equivalent Fahrenheit temperature. Okay, so let's solve these one at a time. Let's work with the solution for A first. As we did before, let's first rewrite our equation. So we have C is equal to 5/9 times the quantity F minus 32. Our goal here is to solve the formula for F. I'm going to underline that in the instructions. Solve the formula for F. That means we want to get F by itself. Well, if you look on the right-hand side of the equation, you can see that there are lots of things over there. We've got a 5/9, we've got this 32 that's being subtracted. All of those are standing in our way of our goal of getting F by itself. So we need to somehow deal with all of those things. The first thing we want to attempt to do is we notice that the 5/9 is being multiplied by an entire expression, F minus 32. We know that because it's in parentheses. So let's see if we can get rid of that 5/9 first. One of the ways that we can clear a fraction is to multiply by its reciprocal. When I say clear a fraction, what I mean is that we're turning it into 1 so that in essence the fraction goes away. So, the reciprocal of 5 over 9 is 9 over 5. If we were to multiply both sides of our equation by the reciprocal of 5 over 9, and that would be 9 over 5 times c is equal to 5 over 9 times f minus 32 times 9 over 5, then we'll be one step closer to isolating the variable f. The reason why is the whole idea of a reciprocal is that when you take a number and multiply by its reciprocal, the product is 1. Said another way, the 5 cancels with the 5, the 9 cancels with the 9. That leaves us with a 1. Anything times 1 is itself. So the right side of our equation now is just f minus 32. The right side is 9/5 c. One final comment before we move on to the next step. This idea of multiplying both sides by 9/5 is a result of the multiplication property of equality, which says that if you have an equality and multiply both sides by the same number, it remains an equality. Okay, so we're actually one step away from finishing this problem at this point. The left side has 9/5 c, the right side is f minus 32. We want f and nothing else. In order to get that, we need to get rid of the minus 32. How do you undo subtraction? With addition. So let's add 32 to both sides. So on the left, we'll write plus 32. On the right, we'll write plus 32. We'll draw our line across. Now on the right, we have f minus 32 plus 32. Minus 32 plus 32 is 0, which gives us f plus 0, and anything plus 0 is itself. So the right-hand side just becomes f. Said another way, the minus 32 and the plus 32 cancel each other out. On the left-hand side, we have two unlike terms. One of them is the number, 32. The other is an algebraic expression, 9/5 c. We can't combine those things, so we're just going to write the two of side by side, 9/5 c plus 32. Once we do that, we find that we have actually solved this literal equation that was given to us in terms of c for the variable we wanted. We have f equals 9/5 c plus 32. Okay, so we have completed part A of this problem. Now let's attempt part B. Part B says if the outside temperature is 20 degrees Celsius, find the equivalent Fahrenheit temperature. Well, this is actually much easier now that we already have solved our literal equation for f. Let's rewrite it. So we have f is equal to 9/5 c plus 32. For this problem, we are told that c is 20 degrees. The reason we know that is because it says if the outside temperature is 20 degrees C, 20 degrees Celsius. Well, Celsius in this particular problem is represented by the variable c. So anywhere we have the variable c, we're now going to replace it with the number 20. This will give us f is equal to 9/5 times 20 plus 32. So now we have to figure out 9/5 times 20. Well, 20 is a whole number, 9/5 is a fraction. In order to multiply those two things together, we'd like to turn 20 into a fraction. To turn a whole number into a fraction, just stick a 1 under it. This gives us 9 over 5 times 20 over 1, and then we still have this plus 32, which we'll deal with once we're done multiplying our fractions. It's always a good idea to simplify before you multiply fractions, and in this case we've got a 20 upstairs and we've got a 5 downstairs. Of course, upstairs and downstairs are just slang for numerator and denominator. 5 goes into 20 an even 4 times, so I can cancel the 5 and the 20, replacing the 20 with a 4 and replacing the 5 with a 1. This gives me the ability to multiply my fractions. My new numerator comes from the two numerators I have here, which were 9 and 4. That gives me 36. My new denominator comes from my two denominators, which were 1 and 1. So f is 36 over 1 plus 32. I'm sure you know that 36 divided by 1 is itself. This gives us 36 plus 32. And we finally add to find that the final answer here is 68. So f is 68. But that's not the end of this problem. This says find the equivalent Fahrenheit temperature. we need to interpret the result of solving our equation. Well, F, we are told, represents the temperature in Fahrenheit. Therefore, we can write the temperature in Fahrenheit is 68 degrees F. And of course, F stands for Fahrenheit. That solves part B of our problem. I hope this was helpful in allowing you how to learn to solve literal equations. Thanks for listening.